Okay, welcome back. Now our next application topic is going to be linear and angular speeds. Okay, so linear speeds. So let's define some of the stuff, and I'll give you the formulas, and I'll talk through this. So linear speed measures how fast a particle is moving. So to set up the context here, consider a moving particle that's moving at a constant speed along a circular arc, so along a circle. So in other words, think of like let's say a spot you mark on a tire, on a bicycle tire, let's say, and you mark with chalk on a line on the tire. And so consider that where that's moving as the bicycle tire is rotating, that's moving around in a circle. So again, think of that's the idea when you're thinking of a particle that's moving along a circular path. Okay, so now the linear speed measures how fast that particle is moving. Okay, so the distance that particle is traveling per unit of time, and so that's going to be the arc length in this case, since it's following a circular path. That's going to be the arc length, right? That's the circular distance. So it's going to be distance divided by time, right? Remember, velocity or speed equals rate times time, or excuse me, rate divided by time. Distance divided by time. Okay, so that's the same thing going on here. Okay, so distance equals rate times time. Rate or velocity or speed equals distance over time, and so that's what you think about when you think about this angular or linear speed, right? So linear speed, as you would think, is determined that way. So velocity is going to be arc length, right? The distance that the particle traveled divided by time. Okay, so that's linear speed. Angular speed, think about the angle. Angular speed measures how fast the angle is changing per unit of time. And in this case, since we're dealing with a circular path, right? So we're going to deal with the central angle, right? So now this is for angular speed, we denote, well, for linear speed, we denote with V, okay? Arc length over time. So remember, S here is not speed. V is the linear speed, and it's arc length divided by time. Angular speed, which is represented by omega, lowercase omega, which is one of the Greek letters, and that's going to be the central angle over time. Okay, so that's going to be angular speed versus linear speed. All right, so again, just make sure you understand that. Now, there's a relationship. Now, again, to show that there's a relationship between linear speed and angular speed, we're going to use the formula, right? The arc length formula. So S equals central angle times the radius. Okay? Now, what we're going to do is we'll divide both of these by t. Now you can see that this is already V, right? Over here we've got this R over here, so if we take the R and we rewrite it like that, then it becomes what? It becomes V is equal to omega times R. And there's another formula. Now that formula relates the connection or the relationship between linear speed and angular speed. All right, so that's one you want to remember. All right, see you next time.